Scanning the network begins by using various tools and techniques to test for responding hosts. In this segment, we'll learn how to identify live hosts for a range of IP addresses and the importance of selecting the correct IP range. One of the first objectives of scanning is to identify live or responding hosts on the network. This is commonly done by using a technique called ping sweep or ping scanning, which sends multiple probe packets to an IP address range on a network. The packets are specifically crafted to obtain responses and gather attributes. Let's check the Nmap book for more information. I'm here at nmap.org in Chapter 3 of the online version of the Nmap book, which focuses on host discovery. And I'll scroll down where we can see that this section covers methods used to scan a network for hosts. Now I'll go to a new tab because I wanted to show you here that this chapter also outlines the importance of first selecting the correct IP range and to carefully research the target IP range before scanning anything. Well, let's talk about this concept. Network scanning helps develop a profile of a target organization. When properly done, it's a valuable tool for the security analyst. The team can use various tools to determine the IP address of an organization. For example, we can use command line tools such as nslookup, dig, or whois. Or we can use tracer route and ping. We can check email headers, or even use online databases and directories. Let's take a look. I'm here at this website, Netcraft, where we can search web by domain. For example, in this case, I used example.com, and I selected search. And I've opened it in a new tab, and then down below here, you can see where it says Site Report, and I selected that. Now, once I open the site report, and I'll scroll down here, here's where we can find information such as the IP version 4 address and the IP version 6 address. Now, one essential rule to keep in mind is even though you have an IP address, you should double check the IP address or net block. Now, even if the client supplied the address, it might not be correct. As we see here, clients sometimes have out-of-date records or simply write down the wrong information. Now, why is this important? There are certain IP address ranges that are protected from scans, even pings, which mostly include government and military networks. For example, don't scan range 128 or range 129, but there are others. Here I found an exclusion list which lists all the IP addresses that you should not scan. In some cases, they aren't on the list, but they're protected nonetheless. Let's take a look. I've opened a command line prompt and entered ping nationalguard.com, and I'll press enter. We'll see how the request will time out due to packet filtering, or in some cases, a silent discard to the bit bucket. Now let's test your knowledge. Explain how to identify live network hosts for a range of IP addresses and the importance of selecting the right IP range. When scanning, there are several ping scans that we can use to test for liveness. In this segment, we'll compare the differences between ARP, UDP, and ICMP ping scans. First, let's talk about ARP scanning. ARP scanning, also called ARP ping or ARP sweep, is a simple and effective way to determine the live hosts on a local area network. Let's see how this works in Wireshark. I've opened up ARP Scan where we can view the signature. In the capture, we see multiple ARP broadcasts that are sent out onto the network. And I'll scroll down. And any live host will respond with their MAC address. For example, we see in frame 1, the broadcast is sent, who has this IP address. And in frame 2, we see a response. I'm at this MAC address. So we know that the host at .68 is alive and responding. Another scan we can use to test for liveness is a UDP ping. With this scan, Nmap will send a UDP packet to some common ports, for example, port 53, which is used for DNS. It sends it out and will wait for a response. A responding host will return an answer or an ICMP port unreachable error, and not responding or offline, you could see various ICMP error messages. For example, in Nmap, which is the Windows version of Nmap, I use the following command as we see here. And we let this run. And then down below we see the host 10.0.0.1, which is the router, has port 53 open. I'm in Wireshark and we'll see how this works. I've opened up a UDP scan. And I'll go to frame 2. And we're going to drop down the DNS header. And I'll open up the flags. And I'll select the opcode. The opcode for the DNS request is server status request, which is asking, what's your status? And then we'll go down to frame 4, which is the response. In this case, the DNS server returned a response code of 4 or not implemented. This response indicates that it recognizes the query type, but it doesn't support it. However, the server did reply with a recursion available. Server can do recursive queries. With a response from the server, we can safely assume that the DNS server is up and operational. Now, UDP scans are slower and less reliable than other scans. However, they are used many times because they can bypass some firewall rules. Now, the last scan we'll talk about is an ICMP ping, which is a classic example of a ping sweep. ICMP can be used to discover live hosts, detect the presence of firewalls, fingerprint the operating system, and map the network. When using ICMP during a ping sweep, you'll commonly see some query messages. Those include echo request reply, which is used to test for reachability, and timestamp request reply, which is used to compute delay between timestamps. In addition, you'll see error messages, and those include destination unreachable, redirect, time exceeded, and parameter problem. I'm in Wireshark and I've opened ICMP scan signature, where you can see the many requests, replies, and error messages. And I'll scroll down. All total, they provide information about the network. However, keep in mind, when using ICMP ping sweeps, many times they're blocked by a firewall or intrusion detection system. Now let's test your knowledge. Compare the differences between ARP, UDP, and ICMP ping scan. A TCP header has multiple flags that can be manipulated, which can be a powerful ally when scanning a network. In this segment, we'll learn how the TCP SYN and ACK flags can be used to detect live hosts on the network and identify firewall rules. During host discovery, the team will send probes to a range of IP addresses to see which hosts respond. While there are many methods we can use, leveraging the power of the TCP flags can achieve solid results when assessing the network. More specifically, we'll see how using the TCP SYN flag can determine which hosts are alive, and the TCP ACK flag can help determine the presence of a firewall. First, let's talk about how a TCP SYN scan works. The TCP SYN or half-open scan sends probes out onto the network to determine if hosts are alive and responding without making a full connection. This makes it less likely to be logged by certain systems and harder to detect than a full connect scan. The SYN scan is one of the most popular scanning methods because of its speed and also because it's a bit stealthier. Let's talk about how this works. In a standard TCP handshake, the sequence is as follows. From host A, we send a SYN packet to initiate the connection. Host B returns a SYN ACK, and host A returns a final acknowledgement, and that begins the connection. When using a SYN scan, the scanner only sends the SYN packet, or the initial packet in the TCP handshake. And the results are as follows. If the host returns a SYN ACK, that means the port is open. If the host returns a reset, that means the port is closed. No response, or if an ICMP destination unreachable error is returned, this means that the port might be filtered by a firewall. If a target returns a SYN ACK, this indicates that the port is open. In response, the scanner will send a reset packet to abort the connection to make sure a full connection is not made with the target. Next, let's talk about the TCP ACK scan. This scan is similar to the SYN scan, however, in this scan, the TCP ACK flag is set instead of the SYN flag. A key consideration is that the TCP ACK scan isn't concerned about open or closed ports in the traditional sense. Instead, it will help map out firewall rules by identifying whether a port is filtered by a firewall or unfiltered. Responses will be as follows. If the host returns a reset, this means that the packet reached the host and the port is considered unfiltered. No response means that the port is considered filtered by a firewall, which has prevented the packet from reaching the host. Now let's test your knowledge. Outline how the TCP SYN and ACK flags can be used to detect live hosts on the network and identify existing firewall rules. Let's do a challenge. For this challenge, we'll evaluate a scanning signature using Wireshark. For this challenge, we'll begin by going to the exercise folder and opening the file nmapscan.pcapng in Wireshark. And here's what you should see when you open the file. Now, for this challenge, you're going to investigate what's happening in this capture. First, you'll filter by ARP. Describe the pattern you see, and then clear the filter. Filter by TCP. Describe the pattern you see, and then clear the filter. Filter by ICMP. Describe the pattern you see, and then clear the filter. Now let's take a look at the signature. Filter by frame matches Nmap, exactly as it's written. Take a look at the results. How many packets are present? Right-click on any of the packets and then select Follow the Stream. Can you see the text Nmap in the pop-up window? Clear the filter. And then finally, you'll filter by tcp.stream equals 3204. Take a look at the results. What does it say on the user agent line? This challenge should take you about 20 minutes. Good luck! Okay, now let's check our work. For this challenge, you were to open nmapscan.pcapng, and then I wanted you to filter by several protocols. So when we begin, I want you to imagine that you are an intrusion detection system, and you're monitoring all the traffic that goes through your device for unusual or suspicious behavior. And more specifically in this case, we're going to be able to see some patterns of a scan. So first we were to filter by ARP. So we'll go into the display filter and type ARP and then press enter. Now I wanted you to describe the pattern that you see. Well, it's pretty evident that the scanner is actually going through and saying who has this IP address. And it's going through .1, .2, .3, .4, etc. And it will go through the entire range of IP addresses for that network. It's waiting for a response so it can then know that that host is alive and responding. So we'll clear the filter. Next, we'll filter by TCP. TCP and press enter. And then you are to describe the pattern you see. Now again, the scanner is just sending out multiple SYN packets to all the IP addresses in the range. Now if we remember what happens during a scan, that any hosts that are responding will generally send a SYN-ACK back in response to the SYN packet. The scanner then sends a reset so it does not have a full connection with the host. So that's what you see as well. Now we'll clear the filter. Next, we'll filter by ICMP. And then we'll take a look at that pattern. Now in this case, what we're doing is sending a series of ping requests out onto the network. And what we could do, we could filter by destination, so that could just clear it up as well. And what you'll see is it going through a range of IP addresses requesting some type of reply. Remember, the ping request is a test for reachability. Then I'll clear the filter. Now this one we wanted to filter by frame matches Nmap, and we want to do that exactly. So we'll go back in here and frame matches Nmap, and then I'll press enter. Now we see a number of different responses here, and they are related to HTTP. So for this question, how many packets are present? And if you go down below, you'll see displayed 32. Now if we right-click any of the packets and then select follow the stream, and we'll bring this right over here, the question was, can you see the text Nmap in the pop-up window? And yes, right here we see Nmap scripting engine. So there's a signature. Now I want you to clear the filter as well. And the last one is to filter by a specific stream. So we'll go in here and put tcp.stream equals 3204, and we'll press enter. And again, we're going to right-click, follow the TCP stream. And here again, look at the user agent line, and I'll select that. And what that says is Nmap scripting engine, and it refers back to the Nmap book. So clearly a pattern of scanning using Nmap. So understanding how a scan works will help you to tune your devices so you can avoid having scanning on your network. I hope you enjoyed this challenge.